Example 4, factoring the sum of cubes. And so for sum of cubes, you have to know that it's a perfect cube plus, or being added to another perfect cube. And this will factor to a plus b in parentheses for your first factor, followed by a squared, opposite sign of what you start with, minus sign, a times b, followed by always positive plus sign, b squared. And so for example 4, our GCF is 1, and so we identify our GCF as 1, and then we continue to factor as a sum of cubes. To verify that they're both perfect cubes, we take the cube root of each term, so the cube root of 125t cubed is going to equal 5t, and the cube root of 64z to the 6 is going to, the cube root is going to be 4z squared. And remember, with cube roots, 4z squared times 4z squared times 4z squared would give us 64z to the 6, just as 5t times 5t times 5t would give us 125t cubed. And now that we know that they're perfect cubes being added to one another, we can follow the factored form. So our a value, 5t, our b value in this problem, 4z squared. So this becomes 5t plus 4z squared. In the second factor in parentheses, my a value in parentheses 5t squared, opposite sign of what I start with, minus sign, in parentheses 5t times 4z squared, and always positive plus sign. And this, let's see if we can get it to fit at the edge of the page here. Let's write it down here, 4z squared in parentheses squared, and that takes care of the second factor here. So this first factor, there's nothing else that can be done, so we write it as part of our final answer, 5t plus 4z squared. However, the second factor needs to be cleaned up. 5t raised to the second power is 25t squared. Bring down, and then the opposite sign, minus, from what we started with. 5t times 4z squared gives us 20tz squared, 20tz to the second power. And then our last term, 4z squared raised to the second power, gives us 16z to the power of 4. So then it's always positive plus sign, 16z to the 4th. And so that gives us our final answer for example 4.